Hello guys, this is day 13 of our daily push-up challenge while solving a Putnam problem. We're now halfway there to day 25, so let's do this. This is a Putnam problem from 2001. Find all pairs of real numbers x, y, satisfying the system of equations 1 over x plus 1 over 2y equals quantity x squared plus 3y squared multiplied by the quantity 3x squared plus y squared, and 1 over x minus 1 over 2y equals 2 multiplied by y to the fourth minus x to the fourth. So this looks like it's going to be a long problem. So let's insert some push-up first. 1, 2, 3, 4, 5. Okay, and like always, let's write that down here. Okay, so the first thing I'm saying is let's simplify first this equation. Let's distribute these two factors, so we get something like 3x to the fourth plus x squared y squared, but then the middle term is 9x squared y squared, so that gives you 10x squared y squared. And then we have for the last term 3y to the fourth. The other term is 1 over x minus 1 over 2y. So let's just distribute the 2 inside. 2y to the fourth minus 2x to the fourth. And then what we can do is we can add these two equations. Okay, so doing so would give us 2 over x equals, so this gives you x to the fourth because you have 3x to the fourth minus 2x to the fourth plus 10x squared y squared plus 5y to the fourth. And then when you subtract both terms, so the 1 over x cancels, we are left with 1 over y equals, so you have 5x to the fourth plus 10x squared y squared, and then you have 3y to the fourth minus 2y to the fourth, so that gives you plus y to the fourth. Okay, so next set. 6, 7, 8, 9, 10. Okay, so next, what do we do? Let me multiply the equation that I added by x. Okay, so that in order to cancel the the pesky denominators right there, so that gives you 2 equals x to the fifth plus 10x cubed y squared plus 5x y to the fourth. And then the equation that resulted after subtracting, we multiply it by y to remove the y in the denominator. That gives you 1 equals 5x to the fourth y plus 10x squared y cubed plus y to the fifth. Okay, so we are now at 10, 11, 12, 13, 14, 15. Okay, so 15. So now what do we do next? Look, I'm seeing that the coefficients of both equations looks like on the right hand side at least, looks like they belong to the Pascal's triangle. You know, they are binomial coefficients. So let's add these things again. So we get 3 equals x to the fifth plus 5x to the fourth y plus 10x cubed y squared plus 10x squared y cubed plus 5x y to the fourth plus y to the fifth. And then let's subtract these two equations. We get 1 equals x to the fifth minus 5x to the fourth y plus 10x cubed y squared minus 10x squared y cubed. And then you have plus 5x y to the fourth minus y to the fifth. Okay, so look, the first equation, okay, this is the right hand side, is exactly, so look at these coefficients 1, 5, 10, 10, 5, 1. These are the coefficients in the Pascal's triangle, or these are binomial coefficients, and basically this is x plus y to the fifth. Okay, so you expand x plus y to the fifth, you get exactly this one because of the pattern 5, 10, 10, 5. 1, 5, 10, 10, 5. 1. And then, of course, the second one is the one you obtained when you subtracted them. Look that the negative portions are the ones where y is raised to an odd power, correct? So that means this is the same as the first one, but instead of a positive y, you have a negative y, okay, to the fifth, okay? So therefore, this implies that 3 to the fifth root is equal to x plus y, and then 1 is equal to x minus y, okay? So where were we? 15, 16, 17, 18, 19, 20, and then let's finish it. 21, 22, 23, 24, 25. Man, look, they're red again. But yeah, anyway, so from this equation again, we can add to get rid of y. So this gives you, when you add it, this gives you 3 to the 1/5, or fifth root of 3 plus 1 equals 2x. Oh, I pressed home. Sorry about that. Hopefully this opens right away. Okay, so we have this. So we have, oh, it did not save the last things I wrote. So like what I said was, we added this 3 to the 1/5 plus 1 equals 2x, which implies that x equals 1/2 3 to the 1/5 plus 1, okay? And of course, when we subtract it, we obtain 3 to the 1/5 minus 1 equals 2y, which gives us y equals 1/2 3 to the 1/5 minus 1, okay? So these are our final answers. And again, problems like this, you know, where you have a specific final answer, for example, evaluating a definite integral or solving for an unknowns like this one, you can check this in Mathematica. And like I did before when we did an integration problem, I also checked that this, just to make sure that we're doing it correctly. I made sure that when you evaluate it in Mathematica, you get this final solution. So the Mathematica screenshot, I'm gonna put somewhere below this, a screenshot of that. And yeah, this will be it for today, guys. Thanks for watching. I'll see you next time. Bye-bye.